You can't get this wrong. Cannot get this wrong. And here's why. Because if you're a little confused when you first look at it, that is a huge clue about how you should go about solving this, okay? We know that when we're confused by algebra, our goal is to shift away from algebra and try to use arithmetic. The other clue here is that the answers all include the x that's in the question, right? So this variable x is there, but it's a placeholder. It's never something we need to solve for, which means it doesn't matter. So what's our strategy for those situations? We arithmetize. We're going to make up a number to represent x. And because we have the calculator, this is going to be even easier. We're going to do the question with our number instead of dealing with all the pain in the neck algebra stuff that we are likely to make mistakes on. And when we make those mistakes, they're going to show up as answer choices. So we're really saving ourselves a huge headache here and a possible careless mistake. So what is the easiest number for us to work with? It is 0. Ooh, weird. X equals 0. So we're going to use that because if it fails and it works for multiple choices, so what? Who cares? At least it's easy. So my first step now is to take x, or take 0, and substitute it in for all the x's in this equation. I'm not going to start solving yet. I just want to see what I'm dealing with. So I'm going to rewrite it. So the original question is 1.5 times 0 minus 2.4 squared minus 5.2 times 0 squared minus 6.4. So don't try to solve while you're copying, right? The copying could cause an error. So you just want to be really careful checking your work as you go, making sure you're not skipping any steps, doing anything, too fast, right? Take it slow. But now, even without the calculator, I can see some good things are going to happen, right? 1.5 times 0 is just 0. So that's going to already kind of reduce a little bit here. So 0 minus 2.4 squared minus, here again, 0 squared is 0 times 5.2 is 0. So just like that, two of these terms that have squares and are kind of complicated are suddenly gone, right? And we can continue to use PEMDAS to simplify what we have before we start dealing with the more thorough kind of ending in arithmetic that we will need the calculator for, right? So 0 minus 2.4, that is just negative 2.4. And it's still squared. But now we don't have to deal with foiling, right? So if we kept that x, then this original term here would require us to FOIL. And this term here would require us to distribute the negative to both parts. And both of those steps are very high error likelihood here. So that's the thing, is when we're dealing with algebra, we have to do more complicated steps to change our algebra. And so when we have numbers instead of letters, we don't need to FOIL anymore. Foiling is something you only do when you have two terms that you cannot combine that you need to, in this case, square. Distribution is only something you do when you have two terms you cannot combine in parentheses, right? And distribute something to both of them. So those two moves are error prone, but they're only algebra moves. When we have arithmetic, look, everything kind of goes away. And so now I can just kind of do the final arithmetic, and here's where I'm going to start using the calculator. So you might be able to deal with that negative on your own, but I'm going to put it in negative 2.4 squared, and see if I can show this. It might reverse itself on your camera, but you can see that I've put that negative in parentheses there, and that's important, right? So when you are using the calculator, you have to make sure you're entering things correctly. Negatives in particular can get messy. If I did not have those parentheses there, I would get a completely different answer. So I've got to use the parentheses. And when I do, I get 5.76. And here, it's not really distribution, but two negatives make a positive. So that's plus 6.4. And when I add those two numbers together, I get 12.16. Now here's where this question really becomes awesome that we arithmetized, okay? Because we arithmetized a very lazy number, and a lot of tutors will tell you not to use 0 because occasionally it causes problems. And yeah, they're right, it does cause problems, occasionally. But more often, it solves problems. Because think about what's going to happen now as we finish this arithmetize. We're going to plug our same 0 for x into all of these answer choices. And just like it did in the question, 0 is a very special number that makes things disappear, right? So when we plug it in here, I'm just going to quickly show you, negative 2.2 times 0 squared plus 1.6. This term disappears because 0 times negative 2.2 is 0. So in other words, because I picked 0 from the start, anything that's attached to an x in these answer choices is going to just disappear. So what am I left with? Well, in the case of choice A, I'm just left with 1.6, which is not 12.16. So that's wrong. In choice B, I'm only left with 11.2. Again, not 12.16. C leaves me with the thing I want. So that looks pretty good. But let's look at D, 0.64. So A, B, and D, without really doing any actual math other than just understanding how 0 works, go away. And C is very obviously the right answer. Sometimes that will not happen as nicely as it did here. We'll have to the problem with 0 is sometimes multiple answers will give us the same number, and so that's an easy problem to solve. We just choose a new number and try it in the remaining answers. But just as often as 0 fails, it succeeds in a big way. And that's exactly what's happening here, is it's making this complicated algebra incredibly simple and just popping that answer right out. And that's why you can't get this wrong, because you have this tool, arithmetize, that you can use to turn a lot of complicated algebra into very simple arithmetic, and you have to at least try that. And I think that if you get in the habit of reaching for that tool, as soon as you see confusing algebra, you will find that that confusion goes away just very quickly, just as quickly as those variables go away. So this is really an important question. If you're struggling with math, this question shows you how you can still get a lot of stuff right by kind of using these strategies and using the SAT's rules to your advantage. They very often don't want us to solve for variables, which means we can make up a number for them and proceed as if it were the number. And you'll find a lot of stuff gets a lot easier very, very quickly. And that's a good thing.